Hey, so now we're starting a new unit in Module 9. Now, a lot of this information would have been a little bit more helpful, I think, before we did our Module 8 project. But because, you'll see a lot of this stuff like Axis Symmetry, Vertex, things like that could have really benefited you. But hopefully you kind of already got a good understanding on some of that, and it'll make this section even easier. Now, quadratic functions are something that you're going to see a lot of, and a lot of times you usually see teachers come up with a really fancy project for quadratic functions because you see 3 examples on your screen now, and there's plenty more out there. Roller coasters, of course, we saw in the previous section, can be a good use of quadratic functions. Astronauts, of course, NASA's, you're going to use them, and even building the dams, the Hoover Dam, uses quadratics in its design. So it's used everywhere. Bridges are another common example. So quadratics are seen in a lot of places, and they're a big part of engineering as well. Okay, so what we're going to first look at is the axis of symmetry again. So here we have a quadratic function, discover it, chalkboard, blah, 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 x squared plus 6x plus 8. Now, one of the things that we're going to recall, like I said, is that axis symmetry formula, negative b over 2a. So if you look at our equation that it gives us, x squared plus 6x plus 8, let's pull out the whiteboard for this. X squared plus 6x plus 8. Now, a quadratic is of the form ax squared plus bx plus c. Of course, a, b, and c are just going to be regular numbers. In this case, since there is no number in front of x squared, it's actually really a 1. So the a here is 1. The b is 6, and then the c is 8. So our a would be 1, our b would be 6, our c would be 8. And so the axis symmetry formula, which is negative b over 2a, b, of course, is 6, so we'll have negative 6 over 2 times a, and a, of course, is 1. So we calculate that. I like to do one step at a time. So on the bottom, 2 times 1 becomes 2. And so I have negative 6 divided by 2, which is, of course, negative 3. So my axis symmetry is at x equals, because don't forget it was x equals, not y equals, x equals negative 3. Meaning, when you look at a coordinate plane, where you see negative 3 on the x-axis of the coordinate plane is where your axis of symmetry will lie. So it'll be a vertical line through there. That'll be kind of the middle of the parabola, where the parabola kind of lies on. All right. Now, for the example they give here, negative 2x minus 8x plus 9, of course, you can see that their b value is going to be a negative 8. Their a value is going to be negative 2, and their c value is 9, but the c value is not used in the formula, of course. But you still plug it in, negative b, you can see all the work done right here. But you have to pay attention to negative b and b already being negative. So there's kind of 2 negatives. You have the negative that's from the formula, but you also are going to have the negative that's a part of the b value. So you'll see that they've got that double negative action going on. Of course, turns that into positive 8. On the bottom, 2 times negative 2, because remember the a value was negative 2, becomes negative 4, and they simplify this into the axis symmetry being at negative 2 for that example. Right, so axis symmetry is pretty easy. You just have to follow the formula, but be mindful that the formula does have a negative inside it. And when you plug in another negative, be careful about the double negatives. All right, but other than that, other than negatives, you should be fine. All right, now before we do domain and range, before we get into that, let me just real quick assure that we understand the axis symmetry again. So if I give you a quadratic like x squared plus 7x minus 10, right? You have to be able to identify what the a value is, what the b value is, what the c value is, right? So remember, quadratic of the form ax squared plus bx plus c. Remember, this is just a generic form. A represents the coefficient of x squared, which, as you can see, there is no number here, which means it's 1 because it's 1x squared. A lot of times people think it's 0 because there's no number there. But think about it, if it was 0x squared, then you wouldn't see x squared at all because 0x squared means that there's none of them. But clearly there is 1 because it's there. So it's 1x squared. The b in this case is 7, and the c value would be a -10. So since our a value is 1, our b value is 7, and the c value is -10. If I wanted to find the axis symmetry, remember the formula -b over 2a, well, -b would be a -7, and 2 times a being 1, means that this would come out to -7 over 2, which as a decimal could be -3.5. Okay. So again, it's just a simple formula plugging in the numbers. Now let's talk about domain and range. So we've talked about domain and range before. Domain is the span that the graph moves left to right, or how far left, how far right it would go. And the range is the y-axis, which represents how far up or down it would go. So let me use the graph here to kind of demonstrate that. So let me snip this. And let's zoom in on it. Okay. Now, a very important thing to pay attention to here is that we only see a small portion of the graph. We don't see the whole thing because we only see what's given to us on the coordinate plane provided. But the coordinate plane does extend beyond its boundaries, and this graph does extend further past those boundaries as well. So keep that in mind. So domain, remember, we've talked about this in class before. Domain is the span of x-axis, okay? So think about the x-axis. So the x-axis is, of course, the one that goes left and right? So the question here is for domain is how far left and how far right will this graph continue to stretch? Because as you can see, it's stretching further and further left, and it's going up, meaning it's going to continue to further go left. And it does the exact same thing on the right side as well. When you go on the right side, it's expanding. Yes, it's expanding upwards, of course, but it is expanding more and more to the right. It keeps going further and further out to the right. So as it does that, what's going to happen is if this graph goes on forever, then it's going to continue branching out to the left forever. And it'll continue branching out to the right forever, which means the entire x-axis does eventually get used. There's no boundaries on it. There's no limitations to it. It will always continue to go left. It will always continue to go right, meaning it would stretch all the way from -infinity on the x-axis to +infinity on the x-axis. And in which case, we can simply say that it's all real numbers. Basically, every number that's ever existed from -infinity to all the way to +infinity would be stretched out on that graph at one point or another. If you were to, like I said, make that graph expand past the boundaries of what we see in the picture. It would cover every number from -infinity to +infinity because it always goes left and it always goes right. It's never going to stop. So all real numbers is how we illustrate that answer. Now for range. For range, it's the same thing, but it's for the y-axis. Now the y-axis is the axis that goes up and down. So what we're talking about here is how far up and how far down will our graph go. Now our graph does have a bottom limit because here at the bottom it does not go below that value at -7 on the y-axis. Remember, don't look at the x-axis here, that's irrelevant. We're only focused on the y-axis values, okay? So on the y-axis, the lowest this is going to get is -7. It does not exist anywhere below -7. There's never going to be any part of the graph that goes below that line. So it does have a lower boundary or lower limit at -7. But the graph is, of course, going to expand upwards, and it's always going to continue to expanding upwards. There's no limit up there. So that means even past this boundary, it will continue going up forever until it reaches infinity. So its upper limit would be all the way to +infinity. So it spans the region from -7 all the way up to infinity. And another way we could simply write this is we can simply say that it's going to be all the y values that are bigger than, and in this case equal to, -7. Because -7 is the lower limit, and every value that's bigger than -7 is where this graph will take shape. Because it goes from -7 all the way up to infinity. So every value bigger than negative 7. That's how we would write our range. It's not all real numbers like the domain was, because it doesn't use all the numbers, because there is a limitation. It doesn't go down to negative infinity forever. All real numbers is when you say from negative infinity all the way to positive infinity, the entire span. And obviously that's not the case on this one. All right. Your answer. Yep. Okay, so we're good there. Let's see. Comparing properties. The heights of 3 soccer balls are modeled by the function shown below. So one soccer ball, we just see the equation of its, I guess, height. For the second soccer ball, we see a table for its heights. And for the third soccer ball, we see the actual graph of it. Now, which ball gets highest off the ground? And how we would answer this is we would look for a vertex. This has nothing to do with the domain and range, but it looks for the vertex. So here's something that we talked about vertex in 8.07. But we're going to, of course, come back to it more. So when you have a quadratic, like the one, let's look at the first function, which was negative x squared plus 2x plus 7. So negative x squared plus 2x plus 7. The vertex is found through kind of a two-step process, okay? So to find vertex, you're going to need to first find AOS. This stands for Axis Symmetry. I just didn't want to write it all out. Of course, you know that requires the use of a formula that we talked about previously, negative b over 2a. And the second thing is plug in x, okay? The x value, of course, that you're getting from the axis symmetry, it's that same x value. So for soccer ball 1, okay, we are going to use our axis symmetry formula to find the axis symmetry first. So axis symmetry formula is negative b over 2a, x equals negative b over 2a. So our b value here, just remember it's ax squared plus bx plus c. Our b value is 2, so our formula will be negative 2. Over 2 times a. So 2 times a. Now in this case, remember a is the coefficient in front of x squared, and all I see is a negative. Well, that negative means, of course, that it's negative 1. Okay, not negative 0. That doesn't make sense, right? Negative 1. You don't see the 1 written out, but it's up to you to kind of remember that, hey, that there being no number there means that there's a 1 there. So when you simplify this, you're going to have negative 2 on top, and 2 times negative 1 would be negative 2 on bottom. So when you divide negative 2 divided by negative 2, you end up with a positive 1, because 2 negatives make a positive. So x equals positive 1. This is our axis symmetry. Now, we're not done with the vertex yet, because we still have to plug in this x value. So our equation, remember, was negative x squared plus 2x plus 7. But now we're going to be plugging in the 1 in for x. Okay, you have to be real careful with that negative as well. So what we're doing here is we're actually taking 1 and squaring it, which gets us 1 squared being 1. But then this negative gets reapplied to it. So if you type it in a calculator, you would want to type it in like this, where you have negative parentheses 1 parentheses squared. Ultimately, that gives us negative 1. 2 times 1 is, of course, 2, and plus 7. So when you add that all together, negative 1 plus 2 would be positive 1, and 1 plus 7 makes 8. So this is our y value now. Now we're done with all our work. We've got our answer. Our vertex, remember, vertex is a point, okay? Our vertex is the x value of 1, the axis of symmetry number that we got, and the y value of 8, which is what we get from plugging in. So the two-step process that I listed out earlier, well, the first step is basically to find the x value of the vertex. And the second step is to find the y value of the vertex, because the vertex is a point. It is an ordered pair. So basically what this means is that at 1 second, the ball was 8 feet in the air, and that was the highest it got. So for soccer ball 1, its highest was 8 feet. Now, we don't have to do any more work here, because function 2 and function 3, soccer ball 2 and soccer ball 3, they're already sort of on the graph. So if you, let me snip it. If you look at the table for function 2, you'll notice, did I not snip it? There we go. If you look at the table for function 2, the highest it's going to get is 4 feet. Obviously, function 1 beats it because remember, function 1 had a vertex at 8 feet. So this is shorter than that. Function 1 is currently higher. And then, of course, you got the graph. The graph is pretty easy on this one. The vertex is all the way at the top. And so that tells us the vertex here is at 4 feet as well. So the soccer ball that went highest is function 1 soccer ball. And again, we found that through the formula and working it out, plugging it in. So you can see that one all explained right here. We go to page 4. Again, nice helpful video. I think she's going to kind of explain a lot of things we talked about. Also want to talk about rate of change. Now, rate of change is not new to us. We've done rate of change before. If you remember the slope formula, some of you guys are going to really remember this. You know, I call it y minus y over x minus x. Okay, slope formula. We're going to be using more of that here. That's all essentially rate of change is. Slope slash rate of change. Okay, same thing, same formula. Okay. All right, so let me talk you through kind of the example they're showing you here, because it might make sense, it might not make sense. So they have the function negative x squared plus 2x plus 7. So they have the function negative x squared plus 2x plus 7. Now, what it doesn't say at the beginning of the problem is it wants to find the rate of change from 1 second to 3 seconds. Okay? I assume, let me go back. It says that at the bottom, right? Average rate of change between when x equals 1 and x equals 3 seconds. So it really should say this question at the beginning. But here's, so when you're presented with that question, here's how you'd go about solving it. So rate of change requires you to know 2 ordered pairs, 2 points, because you need to take the y value of the second point minus the y value of the first point, and then the x value of the second point minus the x value of the first point. So you need 2 points. You need 2 points, 2 xy's, okay? And so these values here that it's giving us are both x values. So essentially, for the points that we're going to use, we already know the x values of both the points. But what we need is the y value for these points. So in order to find the y value for these points, we simply plug in the x values it's giving. So we're going to plug in 1. So when we plug 1 in, we actually already did this in the past problem. This was, remember, negative 1 plus 2 plus 7, which comes to be 8. All right, so, and then we would also plug in the 3 for the next point. So when I plug in 3, this comes out to be, this would be negative 9 plus 6 plus 7. So negative 9 plus 6 would be negative 3, and negative 3 plus 7 would be 4. So now you have your 2 points that you can use in the slope formula. So when it's going to ask you a question, it's going to provide you with the x values of your points. So remember, these are already given to us. All you have to do is simply plug those x values in to get the y values that correspond to them so that you can have your 2 points. And now we just do y minus y. So I'm going to do 8 minus 4 as my y's, and then 1 minus 3 for my x's. So in this case, I'm doing the top equation minus the bottom equation. So 8 minus 4, 1 minus 3. This comes out to be 4 over negative 2, which simplifies to negative 2. So the rate of change would be negative 2. And that's all worked out here. When you click on show me, it'll show you. They get obviously the answer, but I just want to kind of explain really what that was all sort of saying. So on this one, this graph, I kind of don't like it, but it's asking for the rate of change between 0 and 1. So when you look at it, full screen snippet, let's look closely at this. At 0 seconds, the height of the ball is 0 feet because the y value at 0 is at 0. So we have the point essentially 0, 0. And so at 1 second, which is here, we kind of have to trace this up. It's not a very good graph. We end up right there, which if this is about 3, then that intersection is about 3.5. So at 1 second, the height is about 3.5. And so now you just simply use those 2 points in your slope formula. Remember, y minus y over x minus x. So y minus y, let's do the second one minus the first. So 3.5 minus the 0. And then x minus x, the 1 minus the 0, 1 minus 0. So that just simply becomes 3.5 over 1, which is just 3.5. So that one's just kind of using the graph. It still requires you to use 2 points. So remember, you still need 2 points in order to use the slope formula. So at 0 seconds and at 1 second, you have to look for the y values. In the previous problem, we actually plugged in the 0 and plugged in the 1, or, it was actually, we plugged in a 1 and we plugged in a 3. But we plugged in the numbers to get the y values. But here on the graph, you just have to look at the graph to find the y value, to use it, okay? But either way, you still need 2 ordered pairs before you can use your slope formula in order to find rate of change. Now, transformations. Okay, so transformations is kind of a shift of the graph, moving the whole graph left or right or up or down. Even resizing it can make it look skinnier or fatter, depending on what you multiply it by. Okay, so let's see. Let me click on this. Horizontal shift. So this is when you are adding a value inside the quadratic where you have the x squared. You're adding or subtracting a number to the x inside of that component, right? So if you add 0, obviously it's not going to move. But if I do plus 1, you see where the black line was? The black line, or the line right here in the middle, that's where it starts, right? But the red line is moving it. So when I do plus 1, it moves it to the left 1. If I do plus 2, it's moving to the left 2. If I do plus 3, it's moving to the left 3. Of course, if you subtracting 1 would move it to the right 1. Subtracting 2 would move it to the right 2, and so on. Subtracting 3, subtracting 4, right? Moves it to the right 3 and 4. So it's kind of opposite from how it goes, right? You would think adding a value would move it right, but it doesn't. Adding a value is moving it left, and then subtracting a value is moving it right. So it's kind of inverted. We had seen something like that somewhere a long time ago in class. Vertical shift. So vertical shift is adding a number not where the x is, but adding the number at the end after it. It's not in the x squared. The x squared part is here. It's not in, kind of inside this. It's after the fact. It's behind the x squared instead of in the x squared. So remember, look at the previous one. It was literally in the x squared. That's why the parentheses were there. But in this case, the vertical shift is not in the x squared. It's after it. So when you add a number like plus 1, you'll see the graph is going upwards. And when you subtract the number, the graph is going downwards. Now, it kind of looks like it's getting skinnier and wider, but it's really not. It's just the fact that the graph, the part of the graph that you can't see. If you could see more of the graph, you'd be able to see it better. But yeah, so adding 1 is just moving it up 1. Adding 2 moves it up 2, and so on. Subtracting it moves it down. All right. So let us see if there's any examples for us to work out. Okay, so here, if we want to fill in the blanks, right? So we have our quadratic, x squared minus 5x plus 6. So let me write that down. We have x squared minus 5x plus 6. All right, the first thing it's asking for is vertex. So remember, the vertex is a 2-step process, okay? I told you it before. First step is going to be the axis of symmetry, and the second step is plugging it in, okay? So for this graph, which let me just make sure that I've written it down right. X squared minus 5x plus 6. Good. All right, so the axis symmetry formula, remember, is x equals negative b over 2a. So our b value here is a negative 5. So when I plug that in as negative b, I'm going to have the negative from the formula but then I'm plugging in the negative from the -5. So I have a double negative going on. Then I've got 2 times a. A, of course, is a 1. Since there is no number in front of x squared, it's a 1. Which, when I calculate that, that negative turns into a positive 5, and then 2 times 1 turns into 2. 5 divided by 2 is simply just 2.5, so 2.5. So we're not done with the vertex, though, right? We have the x value is 2.5. But now, in order to find the y value, I have to plug the 2.5 in. So my equation, I'll have to do 2.5 squared minus 5 times 2.5 plus 6. Now I'm going to grab my calculator for this. So 2.5 squared is just 2.5 times itself. So 2.5 times 2.5 ends up to be 6.25 minus 5 times 2.5, which is, so it's going to be minus 12.5, and then plus 6. So when I put all of that together, 6.25 minus 12.5 plus 6, I end up with negative 0.25. So this is my y value, negative 0.25, which means together my vertex is 2.5 and negative 0.25. So when I go back to this screen, I'm selecting that option. Right here, this third one is what it would be. All right, the axis symmetry we've already found. Remember, that was the x value at first, so that was the 2.5 we got before. The domain, well, it is a quadratic, just like the other quadratics we saw. Now, you don't have to go to a graphing website like Desmos or anything. Any quadratic is always going to be a U-shaped graph. If it's a positive quadratic, like a positive x squared, as this one is, it's going to go upwards. But if it was a negative quadratic, like a negative x squared, it'd still be a U-shape. It would just be upside down. Now, in this graph, we're going to notice that no matter what a quadratic is, it's always going to continue to go left and continue to go right beyond its boundaries. So every quadratic always is going to have all real numbers for its domain. Domain, remember, is how far left and right it goes. And every quadratic is going to continue to go left forever and continue to go right forever. No matter if it opens upwards or downwards, it's always going to continue branching out left, continue branching out right. So its domain will always be all real numbers. So that's for every single quadratic ever. Okay? So since it's an x squared, that's a quadratic, means it's going to have all real numbers. Now here's the catch with the range. So since this quadratic was a positive quadratic, right? It was, let me rewrite it here. It was x squared minus 5x plus 6. Because it's a positive x squared, right? I mentioned before that means that the parabola would open upwards. It would look something similar to this one. Now our vertex is very key here. Our y value of our vertex would mean that the lowest this gets to on the y-axis is down to negative 0.25. That's the lowest it goes, because the vertex would be the tip of the parabola, and if our parabola opens upwards, like it does here since it's positive, that means our vertex is going to be the bottom of the graph. So the lowest point it's going to be is at negative 0.25. And remember, since it's opening upwards, it's going to open upwards forever, so it's always going to be bigger than negative 0.25. So our answer would be all the y values that are bigger than negative 0.25. Now, just to point out something, if it was a negative quadratic, if it was a negative x squared, and our vertex was that same thing, that would mean that the y value would have been the highest, because a negative quadratic opens downwards, which means the vertex is at the top of the graph. So the y value would be at its highest. Okay? So in that case, you'd say that its range would be all the values of that less than negative 0.25. So y is less than or equal to negative 0.25. That would be if, like I said, if it was a negative quadratic, it was flipped upside down. Okay? But as I said, this quadratic opens up, which means this y value is at the bottom of the quadratic, the lowest point. So all the y values are going to have to be bigger than this one, which is why I chose the answer I chose. Okay. So I'm sure there's a few more practice problems we can look at. I'm going to let you guys kind of do those. Obviously, do as many of these as you can. Okay. Let's see, is there anything really else I want to do? I mean, there are these functions as well. So it's still kind of the same thing. X squared minus 2x. Let's look at that real quick. So x squared minus 2x. So it's asking for us to find a lot of things. It wants us to find the axis symmetry, vertex, x-intercept, y-intercept, and range. So let's do all that. Axis symmetry, vertex, x-intercepts, y-intercept. And did it say range? Let me check. And range, yes. Okay, so how are we going to do all this? Well, first thing, axis symmetry is easy. We have our formula, negative b over 2a. So this doesn't have a c value because this has an x squared and an x term, but it doesn't have the number at the end. So there is no c value here, or essentially you can think of the c value as just being 0. But our b value is negative 2. So this would be a negative 2 for the formula. Over 2 times a, of course, a would be a positive 1, so 2 times 1. Which means that our axis symmetry would come out to positive 2 over positive 2, which means 1. So axis of symmetry is x equal to 1. Now for the vertex, we already know the x value is 1 because that's the same as the axis symmetry. All I have to do is plug this 1 in to the equation to find the vertex. So the equation x squared minus 2x, plugging 1 in. So we're going to have 1 squared plus 2 times 1. And that's because, like I said, the axis symmetry value is 1 that we're plugging in. So when I calculate that, that's going to be 1 squared is 1, minus 2 times 1, which is 2. 1 minus 2 ends up to be negative 1. So the y value would be negative 1, and there's my vertex. Already done. Now the x-intercepts. This is a curious one. So the x-intercept is found from factoring, like we did before. So when we have x squared minus 2x, we're going to set this equal to 0, and we're going, because we're finding x-intercepts are, again, also called zeros. Saw that in the previous section. And we're going to factor this. Now, both of these terms, we're going to factor this by GCF since it's only 2 terms. Both terms here have an x in it, so I'm going to factor that x out. So that x comes out, and it leaves us with x minus 2 as a result. And so now it's done factoring. We factored just the GCF of x out. So I've got 2 components here. I've got this plain x right here that needs to be set up equal to the 0, and I have the x minus 2 as well here that needs to be set up equal to 0. So I've got 2 groups to solve. Now when I solve the first one, x equals 0, it's pretty much already done. X is equal to 0. But the second one, I would have to add the 2, and I'd solve that and end up with x equal to 2. So I've got 2 x-intercepts, one at 0 and one at 2. So essentially I would have 0, 0, and the other one would be 2, 0. Again, these are ordered pairs. These are the x coordinate points that they would cross. It crosses at x being 0 and x being 2, which means the point would be 0, 0, and this point would be 2, 0. The y value is going to be 0 in any of these points, so that's not going to change. It's just the first number is the x number, right? X being 0 and x being 2. The y-intercept is also a pretty easy one to find. All you have to do is plug 0 in to the actual equation. So the y-intercept, we just make x 0 and we just plug it in. So here's the equation again, right? I'm just going to literally plug 0 in. This is how I get the y-intercept. So 0 squared minus 2 times 0. Obviously, this is going to be 0 minus 0, which is still 0. So the y-intercept here is simply at 0. You can also write it as 0, 0. And then lastly, the range. Now, we're not going to actually graph this function, but we have to use what we know. Remember, we know that this quadratic function is a positive quadratic because it's a positive x squared, which means that this graph would open upwards like this. So the vertex would be at the bottom of the graph, given the fact that it opens upwards. Remember, we know that the vertex is at 1, negative 1 from earlier. So I'm not going to actually make the graph, but here's the thing I want to point out. The vertex is at the bottom. In this case, since our graph opens upwards. And the bottom, the lowest, we really just focus on the y value here. The lowest, bottom, meaning lowest, the lowest that this is going to go in respect to the y-axis is -1. So that means our range is going to be all the values of y that can be bigger than -1, since -1 is the lowest number. So everything else can be higher than -1. So our range would be the y values greater than or equal to -1, because everything, if this was -1 on the y-axis, the graph is going to be above -1 since it opens upwards. So y is greater than or equal to -1. And so that's how you would go about doing all those things for number 1. Okay, it gives you the answers. Obviously, those are all the answers. But, I've worked everything out for you there. And you would do the exact same thing on question number 2. So I'll let you guys try to practice that one. It gives you all the answers as well. But please make sure you're going through the process like I did. One thing to point out is they say the axis symmetry is -1/2. That -1/2 is the same thing as -0.5. Like I said, the axis symmetry, this is the x value of the vertex. So if the x symmetry is -1/2, the x value of the vertex has to be -1/2 as well. But they've just written it once as a fraction, once as a decimal, but they are the same number. So please make sure you're capable of doing that. If you have questions about that one or want to see it worked out, just let me know. And then yeah, you've got more. But that's kind of the idea of getting the axis symmetry, the vertex. You already know the zeros. Remember, the x-intercepts come from factoring, okay? The y-intercept comes from plugging in 0. Remember those things, okay? It's not just the way it is on one example. That's the same way it is on all the examples, okay? But I'll leave this video here. I hope you guys do well on your quiz. Remember, you have 3 attempts. If it doesn't go well, just let us know. We'll give you some feedback. We'll help you out so that maybe on your second or third attempt you can do better. I'll see you guys in the next one.